Welcome to Mechtronative Channel. Before you go for the SolidWorks drawing section video, please watch this small section also, what I'm going to tell. Please don't skip this part. In the screen, you can see this is the standard guidebook for the V-belt drives and V-belt designs. So I have attached the link of this guide in this video also. For this V-belt design, I have chosen the belt type as type A belt. You can see in table 1, page number 65, you can see the type A belt. Here you can see the illustration of the belt cross section. So for the type A belt, the nominal top width should be 13 millimeters, the nominal height should be 8 millimeters, and the nominal included angle should be 40 degrees. And last, pitch width is 11 millimeters. Let's go to the page number 75. On page number 75 on this book, you can see the cross section area of the V-belt pulley. So these are the markings here, and L should be the total length, and this one should be the groove angle in outside diameter, and DP should be pitch diameter, and pitch line also marked here. And on page number 76, you can see the dimension of standard V grooved pulleys are mentioned. So please search for the type A belt. For the type A belt, you can see for the design requirements, our large pulley should be 300 millimeter of diameter, and the small pulley should be 100 millimeter of diameter. So the pitch diameter of the pulley should be selected from here. So for first we will select for the large pulley. Large pulley's pitch diameter is 300 millimeter. So 125 and over. The groove angle should be we are taking for 38.5 degrees, and the minimum top width groove should be 13.3 millimeter, and the outside diameter should be 12 millimeters. Center of the groove is we are taking 15.3 millimeters. The edge of the pulley to first groove center we are taking here 12 millimeters, and the minimum distance B is 3.3 millimeters, and the groove pitch width should be 11 millimeters. For the smaller pulley pitch diameter is 100 millimeter. So this will belongs to this table. So 75 recommended minimum and under 125. So groove angle we are taking is 34.5 degrees, and the minimum top width of groove is 13. So this is the minimum angle we can have above this range, and the minimum groove depth should be 12 millimeters. And again we are taking the center to center of grooves distance would be 15.3 millimeters, and here F also 12 millimeter as same as the large pulley, and the distance B is 3.3 millimeters, and groove pitch with this 11 millimeters. Okay, now let's draw large pulley. First choose front plane and go to sketch. Draw a center line of 85.2 millimeter of length. Okay. Now draw another line from the origin vertically. This is half of the pitch diameter, which means 150 millimeter. Okay, click OK and draw another line also. Draw another center line of 3.3 millimeter from this point. Okay. Now draw two reference center line from these two lines horizontal. And to another two lines. And measure it. Now zoom a little bit this top area only. Now start drawing. Draw a inclined line here and mirror and tie this. So select this line and mirror above the second vertical line and define this distance, which is it is 11 millimeters. And click OK. And groove angle should be 38.5 millimeters. Right. And draw another inclined line and place it arbitrarily and make a relationship between these two lines. First one and second one. Make it collinear. Right. Then mirror this line also. Select this line. Mirror above. Now select topic and define the distance from outside of the diameter to pulleys V grooves bottom part. As a standard minimum height is 12 millimeters. Right. Now check this line to this line whether it is 13.3 or not. Okay, this is 13.3, so we can drawn this section correctly. Now connect these two lines. Draw a horizontal line. Now design The total number of grooves for the belt should be 5. So we have to make these kind of V-shaped grooves numbers of 5. So select linear sketch patterns and scroll it down and select this entities to pattern. Select the first line, second line, third, fourth, and select 5. The distance is 15.3 millimeters and switching to reverse direction. Now OK. And draw a line here to here. The same line here to here also. Okay. Select this line and top of the line and make it vertical. Define these 2 points. This distance is all about the shaft distance, the hole in the pulley. It is based on your requirements. I'm just placing the diameter of the pulley's shaft should be 50 millimeters. So here type 25 millimeters. So connecting all the lines. Okay, we are done with the drawing. How about the features? Select revolve boss. Okay, contrast. This the axis of your revolution is the bottom part of the line. The cross section is B. 1, 2, 3, 4, 5. So we have successfully created a large pulley with 5 grooves. At last we have to define a plane. So select one of the large pulley faces. And here the distance should be 12 millimeters. And don't forget to reverse or flip the direction. Okay. Photo sketch in the plane one we have created and draw a 300 millimeter its diameter of circle. Then save this sketch. Make a length of 85 5.2 millimeters of horizontal line. And draw a vertical line of 50 millimeters. So another center line. It is a vertical line and it is 3.3 millimeters. Now we have to define distance F and distance E. Draw vertical lines here. So draw another line on. Okay, define the distance between each lines. The distance F should be 12 millimeters. The second distance E should be 15.3 millimeters. Okay. Zoom this part only. Okay. Now draw incline line here. And mirror this line using mirror entities. Select this line and mirror about the second center line vertically and click OK. This point and this point distance should be 11 millimeters. Now we have to define the groove angle, which is for smaller pulley 34.5 millimeters. Height of the rig, which is 12 millimeters. Now measure this distance. Okay. Now the distance is, according to the guidebook, the minimum distance should be 13 millimeters. So we have safety margin with the 0.05 millimeters. Now, okay, I draw this line. Now we have to make it as a 5 groove. So with linear sketch. To be a little bit. And write this pattern. First line, second line, and the third line. Fourth one, and the fifth one. And scroll a little bit up. Okay, the direction is good. The count should be 5, and the distance should be 15.3 millimeters. Now draw these remaining lines also. This is about 5.48. The another one should be also 5.48. Okay. Now fill these gaps between these color points. Now sketch remaining lines also. Drag this line, make it vertically for 10 millimeters. We will define as 10 millimeters. I click OK. Now connect remaining all lines. Okay. Now go to features and go to revolve boss. And then axis of revolution should be bottommost line. Same as in the previous step, we have to define one plane and select this face and pick the direction. Click OK. Okay. Now select and go to sketch. Here we sketch the pitch diameter of the smaller body, which means it is 100 millimeters. Okay, now exit sketch. Then save this part also. Assembly and click OK. At first, go to right plane for sketch and draw a horizontal line. And exit from the sketch. Go to assembly and insert components. Select both large and smaller wood. Now select one of the pulley and see whether it is fixed or flopped. To see, go to right click, float it. Now go to mate. Select pitch circle of the larger pulley and select one end of the line and coincident, then OK. Select pitch circle center of the smaller pulley and one end of the line also and make it coincident, that's OK. Click OK. Now go to right plane, select mate, select one face of the larger pulley and make it parallel. Again select right plane and go to mate. Select smaller pulley one face and make it parallel. Click OK. Here rotate each pulley and each pulley should be now rotate independently. First one OK. Smaller pulley, rotate it. Okay. Now it is rotating independently. You may have one question, I think. The reason why I was not made two pulleys faces each other until now is we have one reason. That is the belt should be drive each pulley. So if we made two pulleys faces with each other coincidence, then if we rotate one pulley with another pulley, so the another pulley also rotate. It should not do that because the belt should drive the pulleys. Now we will create the belt path. So go to assembly features, go to belt chain and select larger pulley pitch circle and smaller pulley pitch circle also and scroll it down and tick create belt path and click OK. And please save the assembly first. And go to plus icon of the belt and go to belt part and open part. First go to features and select reference geometry, plane and click one point of the pitch circle. I am taking here the large circle and select the line also. Click OK. Now zoom a little bit. Go to sketch. Select the center line. So draw a vertical line here. Now make one relationship between this point and the origin. And make it coincident. Okay. Now draw a horizontal line, the width of 13 millimeter. And select the both endpoints of the line. And the center line we have created. And make it symmetry. And click OK. Now draw an inclined line here, and the height should be 8 millimeters. And mirror the line also, like this line, and mirror about the center line. Click OK. The nominal angle of the V-belt should be 40 degrees. So it is according to the belt guide selection book. Okay. Now complete the sketch first. Okay. Now slightly move the drawing down, please. Okay. We have to define on the dimension 4.96 millimeters. Click OK. Now see the sketch. Go to features and select swept boss. Go to the profile. Already the sketch is selected, and we move to the path. Select the belt path. Click OK. We will define one material. Go to appearance and color. Select rubber, matte, and matte rubber. Save. Okay, you can see now we have successfully created the belt part also. So we will hide all the sketches here first. Now we have to make another 4 number of belts. So use linear pattern to make it easier, and you don't need to design it from the beginning. Let's make it. Go to linear pattern. Select components to patterns should be the belt one. And select the temporary axis also. Okay, now go to direction 1 and select the temporary axis. We have to make 5 number of belts and reverse the direction. Okay, 15.3, which is the distance F. Click OK. Now you can see each belts are correctly seated. So we are done with the belt also. Select the larger pulley and rotate it. See, the smaller pulley also rotating. So the belt is driving correctly. Now we will do a simulation. Before the simulation, we will make one change in the larger pulley. Before that, we have to mark some symbols on the top of the pulley's face. During the simulation, it will help us to see the rotation of the pulley. I'm just making a symbol on top of the large pulley, and select the top face. For sketch, draw center rectangle. Go to features and extrude, and we will give a color point. Click OK. Okay, now save this. This is not the necessary one. Just showing the pulleys are rotating. And exit. Go to motion study and first select the motor here and select the rotary motor, and the component of direction should be, I select this face, inside face. So click OK. Before that, set the speed. We will keep it as 200. Okay. And drag the timeline here. We drag the timeline into 10 seconds and start calculating. It will calculate to play the simulation. See, if you want a realistic mechanical part like this, we can use Keyshot Rendering software. This software is very useful when you need a cinematic appearance with the high quality rendering like this. Before you go to the Keyshot software, let's first convert the files into step file. Here we need to convert the assembly file only to see in the step file type. So let's make it. Go to SolidWorks and select the assembly. Click open. Now go to save and make it as save as. Click the save as type as and expanding it, and select step AP214 file type and name it and please save. Okay, the step files are converted. Now open Keyshot tab. This is the user interface of Keyshot 8.2 Pro edition. You can see my recent rendering, and we can close this and first go to file and click import. Go to assembly as step file and click OK. Open. Click import also. First you save the file as Control S and save. Now first go to edit, edge geometry, add plane. Click OK and select the plane and scale it to a large number. 1000 to 10,000. Okay. Now click the plane. Go to materials. Now the material list is open and scroll it down. Go to glass and select glass solid. Double click it and drag it to the plane. Okay, so the plane is successfully using the environment. Now you can see the reflection also. Now select the pulley, larger pulley, and go to metal. Select basic and scroll it down. Select this one, metal polished one with blue color, and drag it to the larger pulley. And now we will move to the smaller pulley and select the same material as well. Double click it and drag it to the smaller one. And go to plastic and scroll it down again. Go to rubber and select the rubber roll. Now everything is done, and see the realistic rendering comes out very well. And the file paths and all, and select the render. Now you can see the rendering is started. Okay, now the rendering is successfully created. And this is the belt and pulley rendering from the Keyshot that we have created. I think you have gained some knowledge regarding 3D CAD. Thank you, and please support me, and please forgive me for any delays in videos and quality audio as well, because this is my first YouTube video and I'm doing this video with the very limited resources like old laptops and old components also. So upcoming videos will be definitely improved in audio and video quality as well. Please share, like, and subscribe. Thank you so much.